One, two, three.โลหนึ่งสองสามโลหนึ่งสองสาม So, good morning, everybody. Welcome you to SCI33205, and we arrive at this is for M604, right? We arrive at the fourth chapter. Yeah ผมทวิตอยู่ที่YouTube นะครับ how it is there. Okay. I hope that everything is alright. And only two people have okay. Or maybe these, but just have many words of the but I improved something. Five. Yes. Five. ผมเพิ่งเรียกว่าอะไรครับปรับปรุงไฟล์ครับก็เลยอยากใช้อันล่าสุด Okay, here we start our lecture from how we it's there. It's let me capture stuff. He include and then always. Yeah. Here we. I hope the sound is all right. So I need to more the possibility. Yeah, please. Okay. I hope that เข้าใจว่าทุกคนจะได้ยินเสียงผมนะครับก็จะเป็นมีคลาสสิกครับส่งไฟล์ให้อีกนิดนึงครับก็จะเอาเป็นบทที่ในการ Okay. All right. I hope that everything is fine. ก็พื้นที่กันมามีทีมอักวัดแค่นี้นะแต่เข้ามารอที่ตรงนั้นก็เยอะอยู่นะครับที่YouTube ครับมีปากพาวิทย์นะครับมีธนนัทนะครับ Yeah. Okay. I hope that everything is fine. Okay. I see it from you, man. Okay. All right. Here we have talked already. Oh no. Yeah. The bigger scale for theผมเช็คซาวด์นิดนึงครับเสียงมาไม่มาครับ All right. Hello. Yeah. Okay. All right. Yeah. Here. All right. The sound, the audio is all right now. Oh, ผมเข้าอีกเครื่องแต่ผมต้องปิดเสียงใช่ไหมต้องลดเสียงไป All right. ถ้าฟังว่าเสียงใช้ได้ครับเห็นได้ครับเห็นได้นะเช็คที่ตรงนี้แล้วกันนะครับ one. Okay. It seems that the audio is fine. Okay. ที่ YouTube เสียงใช้ได้นะครับ YouTube ก็สุภสินธนนัทเพชานะครับแล้วก็ประสิทธิครับเสียงที่ YouTube ออกไม่เลยที่ซูมเสียงออกนะครับคราวที่แล้วเสียงไม่เข้านะครับก็ไม่มีใครบอกผมนะครับ I hope that everything is fine. Yeah, the capital calorie is a bigger version for the same thing, which is the units, of calorie. Yeah. So we have to talk a little bit about the unit, but it's quite rare, okay, except that you pick up the problem from any book in chemistry. Yeah. The capital calorie is the 1,000 higher version of the small calorie. Yeah. Okay. It's instead of 4.186, it's equal to 4,000. Okay, 4,000 and 186. All right. And yeah, we will. It's quite rare for us in physics that we face with or we encounter this scale of the heat. Okay, all right. Yeah. Internal energy refers to the total energy of all the molecules within the object. Yeah, it's quite important for the succeeding or for the next section that we will have to consider the internal energy too, right? Temperature is related. Now we arrive at the next quantity, which is temperature. All right. How could we say? Temperature is like the height, okay, of your body, and heat is like the weight of your body, and temperature is related to the kinetic energy of the molecules of the material. It is the average kinetic energy of individual molecules. Temperature is commonly associated with how hot and how cold an object feels when we touch it. And an object that feels hot usually has a higher temperature than when it feels cold. In a device of molecular type that is used to measure the temperature is thermometer, right? And we're going to talk about it quite often in this sector. But nowadays there is no only thermometer. There is also other type of device, and that's if you have smartphone and if you download an application that has a functionality of scanning or telling you how hot of any of the keys. So that's a great thing, right? I mean, you can use also your smartphone nowadays to scan any object. If you want to observe or you want to see any temperature, the temperature of anything, right? Especially in the pandemic era, pandemic situation. All right, right there. Okay, now, okay, it's not like my generation thermometer is only the single device that we could find at my era. Okay, when I was like 15 years old or 16 years old or 18 years old, something like that. And in that era, it was only one thing, that one device, a single device that can be used to measure the thermometer, especially when we are at the hospital. Okay, we don't use it every day. But in some other countries, for example, in a country that has a really cold weather, they usually have the thermometer at home, okay, in order to observe the weather. Okay, they would make a decision whether they will wear a jacket or they want to go outside, out of the building or in residence. Okay, yeah, thermometer can be seen here in figure number 1. All right. Yeah, it consists of the glass, right? And we leave the mercury. Okay, usually we use the mercury. Some in some thermometers they use the the ethanol. Okay, it's a kind of alcohol. Yeah. When system becomes hotter, the liquid inside, okay, whether it's mercury or ethanol, we're gonna have the expansion of the liquid inside. Okay, so when we get hot, when we get more heat, okay, in the expansion of the rising level of that liquid is going to be higher. Okay. ขออนุญาตเช็คซาวด์ตรงนี้นะครับว่าซูมเสียงไปหรือเปล่าครับคุณอยู่กันหลายคนครับก็ไม่ได้แจ้งผมนะว่าซาวด์ออกหรือเปล่าครับเสียงนะครับเสียงออกอยู่แต่ว่าทำไมไม่รู้ว่าซูมทำไมไม่มีเสียงครับ alright ที่ซูมนะครับซูมมีเสียงนะเสียงครับเช็คแล้วครับ okay yeah, when the liquid expand, we will get the rising level of the mercury or ethanol, right? And the value of L increase. Okay, and we use the scale to measure the temperature of anything. So we have a thick area, okay, of the glass in this case because we want the strength, okay, to hold the piece of this thermometer, and here we need to have the thin area of the glass because we want to let the heat from anything, okay, that we want to measure get into the liquids as soon as possible, okay, because if the glass is bigger, so we have to wait for a long time, okay, when we plug the thermometer into our body, so we have to wait for a long time. But if we have a thinner area for this part, we're gonna get quick results, okay, in measuring any system temperature. Yeah, the next thing is the thermometer in the normal scale rates, you may have ever seen these I don't know, in vacuum free or something like that. You know that if you bring the ice, if you leave the ice into this one, you get you will get zero degree of Celsius. Like if you leave the ice, because if there is no heat at all, and the heat outside get into this area, you will get 0 degree, okay, out of the thermometer. All right, and yeah, that's the basic side. You have mix in vacuum free or something like that. And if we put the heat, okay, from the fire, and we boil it in until it reaches a situation when we have when there's steam or vapor here, and what we could observe from the thermometer is that the temperature here on the thermometer will be at 100 degrees of Celsius, right? And, yeah, that's the freezing point. Okay, and here is boiling point. Okay, that's the basic scale we use to define the scale of the temperature. Okay, we use water as the reference, the freezing point and the boiling point. Okay, the situation we will get vapor or steam. All right. Yeah. Temperature can be measured in several ways. Okay. Liquid, volume of liquid. Okay, that's what you get from the conventional thermometer, right? And next thing is if you have the metal, okay, and you put the heat into this metal bar, for example, you can observe that this metal gets more length. Okay, if you provide more length to you, so it stretches, and yeah, the length of any solid can be used as the indicator to measure the temperature. The next one is that you keep the volume of the gas to be constant. Okay, to keep the gas volume constant, and then if you put the heat into that, you can get higher temperature by observing the pressure of the gas. All right, and yeah, it's not quite stable. You can use. Yeah. The next thing is we keep the pressure of the gas constant. Okay, and we let it be constant, and we can observe the increasing volume of the gas. Okay, only one quality you can keep constant, and then you can observe another one, pressure and volume. And in electrical system, we can also observe the heat or the increasing temperature from the electrical system of the connector. If you let the heat pass on to any conductor, and you can observe the increasing resistance from that conductor. Okay, we also use this one in many applications. For example, we use this one in I don't know, in the radiator in the car. Okay, you know the radiator. ภาษาไทยเรียกว่าหม้อน้ำนะครับใช่ไหมin the radiator in the of the car okay we have a sensor okay that touch the water that flow around the engine right and that sensor use this technique okay when the water from around when the water flown from the engine around the engine gets more temperature, gets higher temperature, the resistance of that sensor is going to be increased. And yeah, we could let the current flow and we can observe the temperature from that property. Another way is that if you look at the file directly by eyes, you can classify the temperature by observing the color of that fire or any object. Okay, temperature is a measure of hotness or coldness of on some scale, but what scale we are going to use? Okay, of course, you may have ever seen the temperature unit in degree of Celsius. Okay, that's the most familiar with. That's the most familiar unit that we have seen when we are in Thailand. But if you have ever been in the United States or even in the British, in the Great Britain, they also use a different temperature unit. Okay, the most familiar one is centigrade. Okay, centigrade seems to be an ancient word. All right, it's not the modern word. And yeah, we use it for long time, even while I was a child in my secondary school. I was a person who is chosen by the school to get into the competition in science and so on, science topic. So yeah, I still was taught to memorize the unit of the temperature by using the words centigrade. Okay, and nowadays the people use doesn't often hear these words, centigrade one. Okay, we want to use the surname of this person. Okay, his name is under Celsius. Okay, or simply speaking Celsius. Okay. Yeah, the Celsius scale is derived from the water property, right? At the freezing point of 0 degree and at the boiling point of 1 degree of Celsius. Okay. Yeah, C can stand for centigrade. Okay, why I was shy, and Celsius is also the C version of the unit, right? But but it comes from the surname of this person under Celsius. Okay, and the temperature for substance colder than freezing water is a negative number in degree of Celsius. Yeah, if you have anything like dry ice and so on, okay, it's on the order of minus blah blah blah. It's a bigger Celsius because it's very very cold. And yeah, if you have been in any area in Russia, okay, in their winter, they would have something really less than 0 degree. Okay. Sometimes in Siberia they have minus 50 degree of Celsius, right? And if you want to keep the meat, okay, you just leave it outside the home, okay, and the quality of the meat is going to be kept well. Okay, you don't need to buy a refrigerator at all. And like I was in Germany, okay, I've done the doctoral degree, yeah, the PhD, or it's not PhD, it's known doctoral degree. While we were in winter, the temperature is less than 0 degree. There was snow, and we just left the bottles of beer outside water at the windows, okay, and that's what really happens when you live in a country that is really, really cold. Okay, yeah, the negative value of on the Celsius degree means something you get frozen. Okay, Celsius scale is used both in everyday life and in science. Okay, if you do the laboratory, most of the measurement rely on the Celsius scale, and if you work in a company, in a factory, most of the things will be measured in Celsius scale. Okay, but there is an exceptional case, for example, in the United States, okay, the USA, and a few other English-speaking countries. I don't know, New Zealand or in Australia. I have never been there. Okay, and the people often use also the people often do not use the Celsius scale, but rather they use the scale. Okay, this person, Daniel Fahrenheit. Okay, Daniel Fahrenheit is a person who observed something about heat and temperature, and he built up his own scale, right? And yeah, it's according to it's known according to his surname. Fahrenheit scale is still the most frequently used temperature unit in the United States. If you have a plan to study in the United States, the people use different units. Okay, they use new way to say about the weight, right, and how they measure the height of their bodies in feet, right, in feet, something like that. And also one of the things, the temperature is going to be measured and not in degree of Celsius, not so often, but they would use Fahrenheit scale. All right. Okay. Yeah. The next thing is we will see the comparison between the Celsius scale. Okay. In modern, if you are the owner of the company that produce the thermometer, okay, you should offer two scale, okay, so that you will have more chance to sell the product in different area around the world, okay, and that increase your opportunity, okay, your benefit, your chance in the market share, and so on. Right? Yeah, in some thermometer they provide two scale simultaneously. The left one is on the Celsius scale. The right one is shown in Fahrenheit scale. Okay, so let's see the basic property of our substance. Okay, we consider the boiling point and the freezing point of the water, right? The freezing point of the water is, as you know, at 0 degree of Celsius, and it's equivalent to what's that? It's equal to 32 degree of Fahrenheit. Okay, exactly the same. And the boiling point of the water is steam, when we get steam or the vapor of water, right, at 100 degrees of Celsius, and you get 212 degree of Fahrenheit. And yeah, the room temperature most scientists refer to is at 20 degrees of Celsius, right? In 20 degrees of Celsius is not the room temperature in Thailand, because we rarely have the temperature at 20 degrees Celsius, except that you stay inside the building and you turn on your air conditioner. Okay, but if you get out of the building, it's quite rare, except that we are in winter. Okay, this is, I would say, the room temperature for the North American people or for the European people. Okay, the body temperature is quite standard in every country. So we often use this value in order to classify which person get trouble with pandemic or COVID-19 or not, right? As the situation goes on, you can see the temperature everywhere. You go to the shop, to any store, right? At the entrance, they often provide a thermometer to measure in 37 is again for the normal or typical I would say typical body temperature, right? Okay. But it's not the case. Okay, you know, under Celsius and under Fahrenheit, they provide temperature scales for different areas around the world. Okay, but mostly they are related to the water rights and several situations outside. But when the science has developed quite a lot, in scientists have found that the degree of Celsius, the Celsius scale of Fahrenheit might not be so convenient in order to analyze some properties of the substance on Earth or even in the space, right? Because they have measured some properties of gas and so on, and they find that another scale would be more appropriate when we do the experiment in science, or when we make the measurement of any object temperature in science. So the people has observed, the scientists have observed the gas and the expansion of the gas and the volume of the gas together with the liquid. This liquid is mercury reservoir. They measure the temperature and the pressure together, right, or along the x-axis, and they found that when we increase the temperature, we get higher pressure, and they make several experiments. Okay? They make several trials, and they found that if they plot the result on the typical graph scale, this side is going to bring you to the same point. Okay, these three trials, these three experiments will bring you to the same point, and this point is equal to minus 273.15. Okay, but for you at the high school level and Mathematics 6, it would be sufficient to use only the value minus 273. All right, yeah, and that would be sufficient. Okay, you don't have to be so precise like me, but in many cases, I often use 273.15. Okay, because I want to be precise. Okay, they have got several experiments, and all experiments bring us to each point, okay, minus 3.15, and this will be the lowest temperature of any substance that the scientists have observed. So how often could we deal with the Kelvin scale, or this scale is called Kelvin. Okay, and we would say at this value, we would say it's the absolute temperature value, 0 Kelvin. Okay, that's the lowest temperature any substance, any object could have. Okay, the scientists believe that. Okay, in the space. Okay, there should not be no lower temperature than this. Okay, and the person who observed first is this person. Okay, in 1948. Sorry, in 1848, we know that the molecule stop moving at absolute 0. Okay, it's called absolute 0 temperature, and he proposed an absolute temperature scale, okay, which is now called Kelvin scale. But his name, why he was born, is not Kelvin. Okay, Kelvin is the length that's what you may get if you live in England, in Great Britain, in the United Kingdom, and you have done a lot of good things. It's like you are the trainer of a soccer team like Manchester United, but I'm not a fan of Manchester United. Okay? And the trainer of the famous trainer of Manchester United is Alex Ferguson, right? Yeah, if you done something that has big impact to society, you may get the rank, okay, from the royal family in Great Britain. For example, Alex Ferguson get the Sir title, right? And yeah, William Thompson is the name that he since he was born, and he made something good to the society in England, and he got the rank which is known Baron Kelvin. He was the first person who got this rank, and yeah, the people just used the surname of his position. It's called Kelvin scale, okay, but his exact name, since he was born, is William Thompson. Okay, yeah, Kelvin scale is the temperature scale that is used commonly in science. Okay, it's not the normal temperature when you touch a coin. When you get into the supermarket or department store, okay, and you want to measure your body in Kelvin scale, okay, no one is gonna realize or understand that, okay, because it's not commonly used in daily life, okay. But if you work in science, if you are physicist, if you are chemist, okay, and you do experiment in laboratory, of course, the appropriate temperature scale is Kelvin, okay, but it's not the daily life scale. Kelvin scale is the absolute temperature scale defined to have 0 Kelvin at the lowest possible temperature. So that's why we call absolute 0. Okay, they believe that I'm not scientist. Okay, I don't have deep knowledge inside. They believe that a matter in the space should have the temperature, should not have the temperature less than this. Okay, and absolute 0 is the temperature at which everything, including air, freezes. So, all right, but I'm not sure. Have you ever seen the air get solid at -273, because it's quite hard to do, to have that environment, okay? The environment with -273 degrees of Celsius, okay, even -70 to keep the Pfizer vaccine. It is also difficult for us in Thailand to have that moment, okay. Unlike other temperature scale, Kelvin scale is an absolute scale, okay. You cannot have any other scale that can capture all the details of the matter anymore, okay. better than this. I'm not sure, okay, because when the time goes by, someone may propose a new thing. If you fall in love with physics or in science, you may work in university or in any research center, and you may develop your own temperature scale that is more appropriate to what you discover in the laboratory. Okay? And when you pass the way, the people are gonna use your surname as the temperature units. All right. Yeah. What else? I think there is also another unit scale, right? The temperature unit, which is called Roman, right? But we would not talk about Roman scale. Have you ever heard the word Roman, right? Roman is the Daniel. It's the Danish name, right? Yeah, it's a kind of temperature scale. Okay, and there is a formula between lower and Kelvin and Celsius too, right? Yeah, but if you are interested, you can browse the information by yourself. Okay, but the name is taken from the Danish people. Okay, yeah, this is the experiment. Okay, in order to find discover how the Kelvin scale emerges. And, constant volume of gas thermometer measure the pressure of the gas contained in the flask immersed in the bath. Okay. Yeah, you can see the volume of gas in the flask is kept constant. Yeah, and by raising up or lowering the reservoir B. All right, yeah, and keep the mercury level in the column being constant. Right, yeah, there is also another thermometer which is uses that idea. Okay, it's called a constant volume gas thermometer. Like this, okay, you can even measure the ice. Okay, anything that has really extreme temperature. Okay, that is what we have already considered. Yeah, this one is also the same thing. Okay, but it's taken from another book. This one is taken from the book number 4. It's from book number 1. Part of pressure with respect to time. Okay, and yeah, this one is more. You know that water it gets frozen at 0 degrees Celsius, and you can get high temperature for the water, and the water cannot be less than minus 273. At this point, okay, everything is gonna be in solid state. Okay, everything will be solid, and that slide show the pots extrapolate to 0 pressure. Yeah, because of the development inside, we need to have the scale. Okay, it's another kind of temperature that is measured in Kelvin. We would say this one is 0. Okay, 0 Kelvin. Pressure versus temperature at constant volume of 3 gases. They use different gases to get these pots. And let's talk about the thing that happened in space in nature. All right. So let's start from the lowest temperature. Okay, the lowest temperature is around 10 let's just to the negative 10. Okay, it's almost zero, almost zero. And yeah, at 1 Kelvin, around something above 1 Kelvin, 2 Kelvin, and so on. The helium gets liquid state. The helium gas, okay, gets the liquid state. And if you are at 11 Kelvin, your hydrogen, okay, hydrogen is a gas, right? But it's gone down to liquid. It's gone down to be liquid. 11 Kelvin, and if we are at 60 or 70 Kelvin, the nitrogen got the liquid state, and the water freezes at what's that? It's 0 degrees of Celsius, right? And it's around 273.15, right? Yeah, the water gets frozen, and at the 1000 Kelvin, 1000 is really high, right? It's around 800 or 700 degrees of Celsius, something like that, and you get or 700 degrees of Celsius. The copper is gonna change their phase from solid to be liquid, right? It's more. And oh my God, it's around 5,000 Kelvin, which is around 5,000 degrees of Celsius too. You can reach the skin, the surface of the sun. Okay, but we would not have any aircraft to get there. Okay, because it will be completely destroyed. Okay, let's go somewhere which is quite far from our Earth. Solar corona has a temperature of 1 million Kelvin. Okay, this is what the scientists expect. They could expect from the color of the lights. Okay, they could not have any chance to get there. Okay, I don't know, maybe in the next million years, the human can develop a spacecraft and so on to get there and to measure the temperature. They measure it by using the spectrum of the lights. Okay, when they observe from the deep space and inside the sun. Okay, the scientists believe that the temperature is around 10 million degrees Kelvin, and hydrogen bomb, okay, which is a kind of nuclear fusion process or something like that, and you would get 100 million degrees of Kelvin. Okay, that's those million, trillion, billion, and so on are quite far from us on Earth, right? But that's what the scientists of physics expect in this space. Okay, and that's why the Kelvin scale is more universal. Okay, can capture the tiniest particle until the biggest particle in space, right? Okay, let's compare all these three temperature scale. Okay, we don't talk about the Roman scale, but if you wanna get some idea, you can go to a website. You can see the idea of Roman scale. C by 5, R by 4, right? That's the equation. Okay, the steaming point of the water is standard one is at 100 degrees of Celsius, and the frozen point for the water is 0 degrees. It's equivalent to 32 degrees of Fahrenheit, 212 degrees of Fahrenheit, and on the Kelvin scale we got we get 373.15. Okay, it's only 100 more than the frozen point, which is 273.15 Kelvin. Okay, and you can see the pitch here between two bars on the Celsius and the Kelvin thermometer would be on the same length. Okay, but the one by Fahrenheit will have tinier, smaller pitch of 2 bars. And what else? Yeah. The absolute zero, which is 0 Kelvin, is minus 273.15, and on the Fahrenheit scale, you can get negative 459.67, and here is the abbreviation. Freezing point of water, 32 at 0 degrees Celsius, 273.15 Kelvin. Normal body temperature, now 37, right? On the Kelvin scale, 310.15. But you cannot say this number to the department store. Okay? Your body is perfect, it's normal. You have 310.15 degrees, but degrees of Kelvin. Okay? The people cannot realize that. Okay? We use the normal 37 degrees Celsius. We talk to each other, and on the Fahrenheit, for example, if you live in the United States, they would use this number 98.6 degrees of Fahrenheit. And the boiling point, okay, if you do the laboratory in the United States, they would say 212, but for almost everywhere in the world, we would say 100 degrees of Celsius. And in the strict laboratory, they would say 373.15 degrees of Kelvin. Of course, let's go on to the other stuff. For example, oxygen try to be in liquid phase at negative 183. It's really hard to get this situation. And negative 78. Okay, that's what in the same level as the keeping temperature for the Pfizer vaccine is negative 70 degrees. So at this level, negative 78 degrees of Celsius, or 195, or negative 109 in Fahrenheit, the carbon dioxide start to be solid. Yeah, the water, okay, this is what we have already considered. There is difference in 100 Kelvin, okay, in between the freezing point and boiling point of water, and also 100 degrees in Celsius scale for the freezing point and boiling point of water. But there are 180 degrees between the freezing point and boiling point on the Fahrenheit scale. They have more pictures. They have more details here. Yeah, if you want to convert the temperature scale from one to another one, you may have to consider this table. If, for example, you want to convert the temperature from Celsius to Fahrenheit, okay, the output is on the left-hand side, the input is on the right-hand side. You get 9/5 of temperature in Celsius plus 32, and you can also, they can also say something like from Fahrenheit to Celsius, you have to use the opposite ratio, the Lewis ratio 5/9, temperature in Fahrenheit minus 32 degrees. Okay. And if you want to convert Celsius to Kelvin, it's quite simple. You just add 273.15 to the temperature in Celsius. If you want to convert Kelvin to Celsius, you just reduce the temperature in Kelvin by 273.15, and you get the temperature in Celsius. If you want to convert the Fahrenheit to Kelvin, it's like you do the change between Celsius and Fahrenheit. the next thing is that you have to add to 3.15 to the result, okay, to get the value for Kelvin. And if you want to get Kelvin from Fahrenheit, you just use this expression. You have to reduce it first by 273.15, and then you convert it by using exactly the same expression. Okay, by 5 and plus 32. Okay, that's the whole thing. Yeah, the formula for the conversion between Fahrenheit and Celsius is number 5. And what else? There is an example in temperature scale conversion. เราต้องจบที่ไหนเป็นใช่ไหมผมต้องปล่อยที่950 Room temperature is known as 25. Okay, some areas say 20, some areas say 25. That's right. And what is the room temperature in Fahrenheit? And what is the temperature in Kelvin? The room temperature in Kelvin. Yeah. Now, ปัญหาพลเน็ตล่มพอเข้าตามสบายสุรปวีขอโทษครับมีโน้ตบุ๊กแบตหมดไปสบายตามสบายครับคุณอยู่ที่ YouTube ก็อยู่กันไปตามสบายนะครับถ้าเสียงติดขัดไงแล้วแจ้งมีคนไหนปกติถ้ามาถึงตรงนี้นะครับเพราะผมไม่ได้ทำโซลูชันนะครับผมจะให้คุณทำนะจะให้คุณแก้ปัญหาก็มีใครสนใจว่าจะทำส่วนนี้ใช่ไหมไม่ใช่หรอกมันไม่มีวิธีทำด้วยหรอกใช่ไหมนี่คนไหนสนใจทำนะครับมีคนไหนสนใจทำได้ทำให้ดูเลยว่ามันตอบเท่าไหร่เพราะใครทำได้ไหมครับเปิดไมค์ช่วยด้วยบางคนอาจจะไปแบบว่าเรียนพิเศษข้างนอกมาแล้วก็บอกได้ครับเดี๋ยวนะทำยังไงเดี๋ยวhow to resolve this นี่ครับพอเป็นออนไลน์ปุ๊บแอคชั่นเราจะไม่ค่อยได้นะใช่ไหมครับก็ตอบแต่ก็จะลำบากไม่เหมือนห้องจริงนี่ผมแรนดอมชื่อนะครับซึ่งมันก็เมื่อนานมาแล้วครับที่ได้สอนห้องจริงถ้าเป็นห้องจริงเราก็จะแรนดอมชื่อแล้วก็ให้คุณออกประทำหน้ากระดาษแต่ว่าบรรยากาศนี้มันไม่มีอีกแล้วไม่ใช่ไม่มีแล้วมันคงนานis there anyone who is interested in solving this problem? Anyone interested in this? Yeah, the room temperature 25, right? So you want to convert it to the Fahrenheit and to Kelvin, Fahrenheit and Kelvin. So we have to see Celsius to Kelvin, and we have constant Celsius to Kelvin and Celsius to Fahrenheit, right? So these it's in F, right? In F is equal to this expression. Number 5 plus 32 by 5. Number 5 of T in Celsius plus 32, and you just leave it. It's number 5 times 25 plus 32, you find that this is 45. That's 45, and it's going to be 77, fine. Okay. And that's it. Okay, one thing that I have to mention. No battery at all. Yeah. What I forget to mention is the following. You need to know that both Fahrenheit and Celsius scale, both Fahrenheit and Celsius scale, okay, would have the small circle in front of that. All right. Yeah. There will be small circle in front of F and in front of C, but for K, which is the absolute temperature scale, there will be no zero at all. Okay, all right. That's one thing you should realize. We don't be trying to write down the small circle in front of A for the units of the temperature. For the temperature by Kelvin, there will be no circle at all. Yeah. All right. Yeah, it's the next thing. Now we arrive at the problem of Kelvin. Right, K is 273.15 plus PC, right? It's 273.15 plus 25, right? So it's gonna be 298.15 Kelvin. Okay, without the small circle at all. All right. Let me change the notation. Oh, it's on page 26. Okay. Yeah, here. Next thing. We arrive at the next example, which is the temperature unit conversion problem. Yeah, we arrive at the next example, and here is the temperature gradient between the skin and the air is regulated by two channels who know these words. มีใครทราบคำนี้มาเป็นศัพท์แพทย์ผมเรียนวิศวะนะไม่ได้ยุ่งกับศัพท์พวกชีวะมานานโหครับไม่คุ้นเคยเลยครับ Is there any idea about cutaneous skin blood flow, right? And if the cutaneous blood vessel ภาษาไทยเรียกว่าเส้นเลือดฝอยหลอดเส้นเลือดฝอยครับ All right, is that correct? ใช่ไหมเอ่ยคนไหนเก่งที่ว่าครับคำนี้แปลว่าเส้นเลือดฝอยใช่ไหมครับyeah, if the cutaneous blood vessels are constrict, the skin temperature and temperature of the animal will be about the same. All right, in when the vessels are dilated, more blood is brought to the surface. Okay, when the vessel is expanded, Okay, and the body uses this system to control the temperature inside our body. And suppose during dilation, the steam warms from 32 degrees of Celsius to 82 in 82 degrees of Celsius, or Fahrenheit, sorry, and convert this temperature change, the temperature change from Fahrenheit to Celsius and from Fahrenheit to Kelvin. Okay, and again, find the difference. Yeah. Is there anybody who is interested in solving this problem? มีใครสนใจไหมครับเนี่ยทำออนไลน์แล้วเปิดกล้องให้เพื่อนดูหน่อยก็ได้ Anyone who is interested มีใครสนใจครับ Anyone who could solve this ในกลุ่มแก้ปัญหานะที่ช่องนี้ไม่มีใครดูก็ประมาณนั้นครับอะไรเนี่ยนะ Okay, yeah. We have to convert first the 72 to 84, right? In F2C, right? F2C. So let's take a look at it. Okay, I also cannot remember. F2C is going to be this one. Okay, Fahrenheit to C, 5/9. Okay, T 72F, right? It's going to be converted to T in degree of Celsius, right? So we formulate this one by using this expression F, right? And minus 5/9. Uh, 32, right? And then 5/9, okay? And we leave the temperature of F into this expression. All right. 5/9 divided by 72 minus 32, and it's going to be 5/9 times 40, right? And yeah, believe it in the calculator. 200/9. Okay, let's say it's 200/9. It should be something around 10 by 9. $200/9. $200/9. It's going to be 22.3. It's approximately 22.3. the unit for it. Yeah. And let's continue our story in the next thing is 84, right? So P, C, right, 5 by 9 of 84 minus 32, right? It's going to be 5 by 9 and 5, 2, right? 5, 2, and it's 60 by 9, all right? And it's use these 260 by 9, 28 or 28 or 8 by approximately, and that's the unit in degree Celsius. And then what else? The difference, right? Difference. So it's going to be delta T in degree Celsius is going to be 28.89 minus 22. 22 it's approximately 7 and 6.67. Another way is that you can change the difference here. You can see the difference, which is 12, right? 84 minus 72, and it's 12. And we just use the 12 times 12 times 5 9. Oh, so it's yeah, right. 6.67. 6.66. All right, yeah, you can use the difference and times the scaling factor 5 by 9. All right, in order to find the difference. Or you can find the difference directly from both values. So let's start the temperature in Kelvin. Kelvin is quite simple. You just use same 3.15 plus temperature in the Celsius. At the first stage, T1 is 22.22, right? So it's 3.15 plus 22.22, you would get approximately 295.37. This is in Kelvin. For the second temperature, you get 273.15 plus 28.89, right? And you get 4 oxidation. เป็นเพลงผมต้องปล่อยคุณแล้วถึงหมายก่อนจบนี้ก่อนแล้วกันครับเลยที่นึงนะผมเซ็ตเครื่องเสียเวลาครับขอจัดจนถึง10 โมงแล้ว 5 and 9 is going to be 4, right? And this is 0 and 1, right? And 1 again. The 2, right? Let me check it. ความชัวร์นั้นมันสอนคุณภาพนะผมพูดผิดคือเซลล์คือความตั้งใจทัชเป็นความคิดได้คือเซลล์คือความตั้งใจ Yes, it's correct. Yeah, it's the second temperature in the difference, right? You want to find difference, so delta T is equal to T2 minus T1, right? And it's equal to 7 and 9.6, 9.3 is 36 and 11.5 is 6, right? Something like that. You can see the difference here. Save this. This is a very, okay, you can see the difference on both scales are the same. Okay? The differences on both scales, whether it's in sales are the same. Okay? 6.67. So the next thing, the next example, right? หนึ่งตัวอย่างครับแล้วก็จบตรงนี้ครับแล้วก็สั่งกันบ้านครับnormal internal body temperature for average healthy humans 98.6 degree of Fahrenheit. Find this temperature in degrees Celsius and in Kelvin. Okay, that's the first equation. Let's do first, okay. Normal temperature is something like that. So we convert it to the Celsius and Kelvin, right? So TC first. TC is 5/9, right? And TF minus 32, right? So leave the 98.6 5/9 and 98.6 minus 32 and use the calculator. We get 5/9 minus 32. We get exactly 37 minus. It's not approximation. It's the exact value. 37 degree of Celsius. Okay, that's the normal body temperature. And if you want to find it in Kelvin, you can add it to 73.15, right? That's the temperature in Celsius. So 273.15 plus 37. So it's going to be 310.15. You look at this thing. Now in the second situation, find this temperature. When it's relaxing or out, the skin temperature is about 2 degrees lower than the internal temperature. And how much lower is the skin temperature in Fahrenheit degrees and Kelvin? So you can see that there is difference in difference by 2 degrees of Celsius, where delta T is 2 degrees of Celsius. And we want to find it in Fahrenheit, right? So you know that if you want to convert TF, right, to TC, right? So it's going to be 9/5, right? 9/5 of let's see. Celsius to find 9/5 and plus 32. TZ and plus 32 degrees. That's so we have. If you want to find delta T in F, right? Delta T F is delta T in C, right? Delta T in F, delta T in C. You just use the factor of 9/5. That's internet connection problem. Lost. there's internet connection. All right. Yeah. Okay. Yeah. You just use 9.5 factor and leave it to the factor. Let's see. Okay. And it's going to be 9.5 and number 2. So it's 18 by 5. Right? It's equal to 3.6 degree of Fahrenheit. Right? But regarding the temperature difference in Kelvin, okay, because of this expression, Kelvin is to say 3.15 plus T in degree of Celsius. Delta TK is going to be directly the same as delta TC. All right, so it's, as you know, this one is the degrees different. Right? Degree different, so it's going to be 2, right? Yeah, and that's it for this example. All right, หมดเวลาเรียนครับก็ 10 โมงครับก็แจ้งคุณนะครับการบ้านครับได้เป็นคะแนนเก็บครั้งท้ายนะครับอย่าพลาดนะครับการบ้านให้เลือกเอานะครับก็คือเรื่องคราวที่แล้วนะคือเรื่องเขาเรียกว่า epsilon t เท่ากับบาร์โอเมก้าไซน์โอเมก้า t ครับแล้วก็ครั้งนี้นะครับเรื่อง temperature change นะครับการ convert อุณหภูมินะครับการ convert อุณหภูมิก็หลักๆก็ใช้ตลาดตรงนี้นะเดี๋ยวผมเขียนใน Google Classroom ให้อีกรอบเรื่องการบ้านครับย้ำนะครับการบ้านนะครับเลือกได้นะครับ2 เรื่องนะครับก็คือเรื่องtemperature change นะครับตรงนี้นะครับก็คือการเปลี่ยนขึ้นของอุณหภูมินะครับอะไรนี้แล้วก็อีกเรื่องหนึ่งก็คือเรื่อง generator นะก็คือ epsilon t equal bar omega sin omega. All right. Is there any question regarding the lecture of today? มีคำถามไหมครับ Do you have any question? If not, we're gonna leave our lecture right now, okay, and see you on next Thursday. Okay, next Thursday. สวัสดีครับ บ๊ายบายครับ ชื่อครับ โอเคครับ SCI33205 welcome you to SCI33205. This is the section for M605, right? And, I have two things to inform you, right? Let's check the sound. All right. Yeah. Two things that I have to inform you is the following. The first one is something about the final exam, right? Yeah, same as in midterm exam. Okay, we are gonna have 2 times for the exam, okay, so that you can get best grades, and you can have more time. And of course, we have the content in the second chapter, right? You can have 1 week to remind yourself about the second chapter, and we would have the final exam on the 10. คนที่หลังครับที่ใช้จะดูเรื่องอะไรโอเคสำหรับคนที่มาทีหลังครับก็จะพูด2 เรื่องครับวันนี้นอกเหนือจากเนื้อหาที่จะเรียนนะครับแจ้งคุณของก็คือเรื่องแรกครับก็คือ the first thing is the midterm exam, the final exam, all right, and because we have 2 chapters, like the second chapter and the 4th chapter that we are doing it right now, and for the second chapter we will have the exam on 10th of September. Is that all right to you? No, 10 is not possible. It would be yeah, it would be possible 10. I hope that, because I have also the class for teaching on the 10. I hope that on 10, which is on next week, right? วันที่ 10 จริงๆผมติดแต่ว่าตอบคุณมันไม่ต้องออกเสียงอะไรครับก็สามารถสอบได้alright. On 10, which is yeah, it's Friday, it's no problem. There is no conflict at all. On 10, we would have the final exam. I'm not sure we will see. Okay. On 10 of September, we would have the final exam for the second chapter, which is something about magnetism and electricity. All right. นะครับขึ้นมาจะทำเพื่อนบอกเพื่อนแล้วนะ And I will tell you later about the number of problems, but it's in the same style as the midterm exam. Okay, you have to choose the number, and the problem is exactly the same as in the lecture notes. And yeah, because I need to have more time, okay, to avoid the error in checking your problem with the exam, okay, to avoid the error. So I need to have more time. Otherwise, if you let me do it for only few days, 1 or 2 days, it's very stressful. It's prone to error. It's quite sensitive to the error. So after 10, we would have the exam again. We would have the exam again on. We would have the exam again on 17. Okay, that's the last day we could do the final exam, and we have 1 week. All right, and yeah, and the final score should be delivered to the school on 19, and the grade submission will be done by your co-teacher at the SK school on 21st. All right, so it's the grade will be filled into the system by your co-teacher, and yeah, that's what we could do. I hope that everyone in M605 has submitted his own homework completely perfectly already, right? And I don't know what's going on with Tidut. Maybe we could leave him, I think, but some of you say that he has left the school because he has got the rights to the military school, and but your co-teacher, the teachers whoผมลืมชื่อผมดูชื่อเล่นครับ okay. Your co-teacher said to me that I have still keep the record for you, so that's why I didn't remove him from any file at all, right? And that's the first thing, okay, all right, about the final exam. 10 next week or next Friday for the second chapter about magnetism and electricity. Anything that is succeeded from the content in the midterm exam, they will have it as the final exam contents until the end of second chapter, and we would have few problems for the fourth chapter, which is the chapter, the heat and gas. Okay, all right, that's the first topic we were discussing, and the second topic is that the second story is that I have to inform you that we would have homework. Okay, I don't know, this might be the night homework. I don't know yet. Okay, the night homework will be the problem about generator, which is epsilon equal bar omega sine omega t. Okay, that's the first choice for you. For the second choice, I'm not sure. For the second choice, I'm not sure. Share screen, not it, right? Okay. For the second choice, the second choice is that you can do also the homework regarding the temperature conversion, which is going to be shown here today for today's lecture. Okay, the problem about the conversion of the temperature units, okay? Celsius to Fahrenheit, Fahrenheit to Celsius, Celsius to Kelvin, Kelvin to Celsius, Fahrenheit, Kelvin, Kelvin to Fahrenheit. we will have 3 examples for the conversion of temperature different temperature units for these. Okay, and you can also choose this one as a choice. Okay, okay. In summary, the first choice for you to do the homework is the generator, okay, which has the formulas epsilon t equal bar omega sine omega t. Bar means BAN, okay, B back, B magnetic field, A is the cross-sectional area, N is the number of turns of the coil, and omega is the angular speed of the rotation axis or the rotor, and sine omega t, right? And that's the first choice. The second choice is the temperature conversion, which is what you are going to see here in today's lecture. All right, everything is fine, right? I hope that nobody is going to have any trouble with the final exam. The exam style would be the same. Okay. Yeah, we have stated already the something about temperature. We have talked about this temperature. Okay, as we know from yesterday, temperature is like the height and the height of your body, and heat is like the mass, okay, mass of your body, and yeah, we have discussed yesterday the temperature, the thermometer that is the tool to measure the temperature, right? The liquid inside can be either mercury or ethanol, it's a kind of alcohol, and yeah, the freezing point for the water is at 0 degrees of Celsius, and the boiling point of the water is the boiling point of the water is 100 degrees of Celsius. And is there anything else? Yeah, the way we could measure temperature could be in many aspects. Could be done in many ways. The first way is that you can observe the volume of the liquid, which is a kind of what you can see here inside the thermometer. All right. The next thing is that if you have a piece of metal bar and you inject the heat, okay, you put the heat to it, and the bar is going to be hot, and it can increase its length. And yeah, that's one way. Have you ever seen the railway for the train? ใครเคยเห็นรางรถไฟครับเห็นรางรถไฟนะครับถ้าคุณไปสถานีรถไฟคุณจะเห็นว่ารางรถไฟเหล็กรางรถไฟมันไม่ได้เป็นเหล็กเส้นเดียวกันแล้วต่อเลยนะไม่ใช่แบบเหล็กยาวเส้นเดียวกันคู่ขนานกันเลยตลอดไม่ใช่เลยมันเป็นเหล็กทีละชิ้นแล้วมาวางเรียงกันครับไม่เลยนั่นแหละท่านลองทานดูเหล็กรางรถไฟเป็นก้อนเดียวYou could see Here, okay, here. You can see, right? You can see here, right? There is there is a space here. Then you can see the piece of metal is not a single one. It's made of two pieces of metal. What is the reason behind it? คุณทราบไหมครับว่าทำไมเขาเป็นแบบนี้ทำไมเนี่ยเหล็กต้องเป็นเหล็กสองชิ้นแบบนี้ตัวอย่างอื่นเนี่ยมีใครตอบได้ไหมครับเปิดไมค์ตอบหน่อยว่าบริษัทเซลล์ลากหาทำไมเป็นสองชิ้นแบบนี้ทำไมเขาไม่เอาเป็นเหล็กเป็นอันเดียวกันเลยทำไมไม่เชื่อมออกติดไปเลยติดกันแบบตามประชาเป็นแน่นเป็นชิ้นเดียวกันทำไมวางเพื่อทำอะไรนะครับมีคนตอบแล้วเนี่ยเห็นใจคุณจะเห็นรอยต่อนี่ตลอดมันจะยาวสัก100 เมตรหรือว่า70 เมตรอะไรเงี้ยมีคนตอบแล้วนนทกรบอกว่าป้องกันการขยายตัวเหมือนกันนั่นแหละครับเรากำลังเรียนเรื่อง temperature ใช่ไหมการวัดอุณหภูมิของสิ่งของเนี่ยคุณเห็นไหมครับเนี่ยร่องสีเหลืองเนี่ยนั่นแหละคุณเห็นว่าเขาเหลืออย่างที่นนทกรบอกนะครับก็คือว่าเหล็กมันอยู่ข้างนอกมันไม่ได้อยู่ในอาคารในร่มมันโดนแดดนะครับพอโดนแดดมันทำเป็นมันเก็ตฮีทมันได้รับความร้อนมันก็เรื่องนี้เลยครับเร่งออฟโซลิดเอาไว้นะครับไอตัวเหล็กรางรถไฟก็เป็นโซลิดเป็นของแข็งชนิดหนึ่งพอมันโดนความร้อนมันจะขยายตัวออกข้างด้วยด้านยาวด้วยพอมันด้านยาวเขาก็ต้องเหลือที่เหลือนะไม่ใช่แบบว่าจับชนกันเป๊ะๆนะครับเป็นคนซื่อตรงเขาก็คงเคยลองสร้างมาแล้วแต่ปรากฏว่ามันผิดพลาดนะพอมันดันกันนะต้องชนกันเลยนะจับวางแดดไม่โดนแดดพอโดนความร้อนปุ๊บมันดันกันต่างฝ่ายต่างขยายตัวนะอันนี้ก็ยาวขึ้นอันนี้ยาวขึ้นมันก็ชนกันเห็นไหมอันนี้เขาเหลือไว้เพื่อว่าเหล็กพอมันโดนความร้อนแล้วครับมันก็จะขยายตัว so we use this principle too, all right, in order to observe the temperature increases of any substance. Another one is the pressure of the gas held in a constant value. If you have a constant value glass, you get more pressure from gas when you put the heat into it in. If you keep the pressure constant, and if that subject can be expanded, for example, the balloon. The balloon is an example. Okay, yeah, this one. If you lay down the balloon outside, very easy to find it. All right, if you have a balloon like this, and if you leave it outside, for example, with the sunlight, okay, it gets heat, okay, from the sunlight, and you can see that if the pressure inside the balloon stay constant, the volume of the balloon is going to be bigger, okay. So that's the case here. This one, we keep the pressure constant, and we fix the pressure, and we get the increase of volume of the gas. Okay. Another way is this one. Okay, this one. Oh no. This one. Here. This. Okay. Oh no, my God. Okay, right here. You know this, right? This is the water pipe. Okay, then the water is the water from around the engine. Okay, it gets heat from the engine combustion. And this one is our tank. It's a piece of sensor. Here, all right. It's a piece of sensor. This one is put into the water flow, all right. And there's black and red one conductor one. And the current will flow from the red one and return to the black one. You know, this is the sensor, and the task of this sensor is the following. If the temperature increases, due to the hot water flowing around the engine, the resistance of this one is going to be also increased. Okay, when the resistance of this piece increases, it will let the current flow more difficult. Okay, there will be less and less current flow. Okay, the current will not flow. The amount of current flows is gonna be reduced. Okay, if the water flow with more heat, more and more hot water, the resistance of this piece is going to be more and more increased. When the resistance increases, there will be less current flow from the red one to the black one. And the car use this signal to measure the temperature of the water in the radiator, okay, in front of the car. All right, yeah, that's the way we use. That's the technique we use to measure the temperature. In many ways, the length of the solid metal and the pressure, the gas, the volume of the gas, by another parameter like water and pressure has to be kept constant. And what else? The electric resistance, right, like the sensor in the radiator, and the color of very hot. Okay, you can also observe several temperatures from the color. For example, the physicists analyzed, okay, or inferred the information of the temperature at any star by using the light spectrum. I don't know the chart of the color, but the physicists use these techniques because we cannot go by spacecraft to a very far star, okay? The star that is very far from us on Earth, okay? Because that will consume, it will take a lot of money to do that, or even it's impossible at all because the star is too far from us. Okay, the possible way that scientists can expect or guess or determine the temperature on any star or planet is to use the color of that star. Okay, and they use this technique to classify the Earth, the planet and the star and so on. Okay, several properties of any star that we are interested in. Okay. Temperature is a measure of hotness and coldness on some scale, but what scale do we use usually? ก็แล้วเราจะคุยกันด้วยหน่วยอะไรเพราะว่าใครก็บอกว่าร้อนครับร้อนมากร้อนน้อยเย็นมากเย็นน้อยแต่ว่ามนุษย์สื่อสารกันมันก็ต้องมีอะไรที่เป็นcommon นะครับไว้เทียบกันไว้คุยร่วมกันเข้าใจร่วมกันได้นะครับนั่นก็คือหน่วยของอุณหภูมินั่นเอง All right, so the most common temperature unit that we are faced with in daily life or we encounter every day is this one. Okay, it's given by this person. While I was really young, like a child, in Mathayom 3, I was chosen as, in primary school, I was chosen as the candidate of the school to attend the competition of scientists of science and so on. Right? In that time, at that time, I was taught to know the temperature unit, and it's called centigrade. Okay, at that time it was called centigrade. It's like ตอนนั้นผม12 ขวบตอนนี้ประมาณ30 ปีที่แล้วครับเห็นไหม30 ปีที่แล้วเป็นเรียกว่าเป็นตัวแทนโรงเรียนครับไปตอบปัญหาเกี่ยวกับวิทยาศาสตร์ and I was taught to get to know the temperature unit, and it's known as centigrade at that time. Okay, but when the time goes by, this word is not used. It's no longer used. You can hear this word in the ancient book. Okay, in the book that is really old. Okay, the very old book. You can hear this one. Okay, it's known as centigrade at opinion. Okay, and C, the C letter is chosen as the abbreviation unit. Okay, you can see C. But when the time goes by, they have changed the new way, the new word. I think maybe this person has added it already. But the C is actually came from the word Celsius, and Celsius is the surname of this person, under Celsius. Okay? And I think it would be very old generation, because if you look at his hairstyle, it would be in the same era, same generation as Napoleon Bonaparte. Because usually we don't have such type of hairstyle nowadays. And the centigrade scale or the Celsius scale is based on the basic property of the water. All right. Yeah, what properties of the water we are interested in? So the scientists pay attention to things. The first thing is the boiling situation of the water when the water changes its phase from the liquid phase from liquid to gas, right? And the next point, okay, the second important point is the freezing point. Okay, that's the temperature when the water changes, again, its phase from solid to liquid or from liquid to solid. It's called freezing point. All right, or melting point. Again, it's the same thing. And yeah, this is built up by Celsius. Okay, Celsius. That's why we say degrees of Celsius nowadays. And the temperature of substance colder than freezing water is going to be considered as negative. Sarah, have you ever been in Siberia? Let's talk about Siberia. Okay, it is a poem. Oh, no, what?ขออภัยครับเน็ตผมดูนะครับหมายก่อนเน็ตผมดูนะครับขออภัยด้วยอยู่ดีก็หลุดนะ All right. Okay, in Thailand, maybe we could not have that situation. Siberia with S. Okay, Siberia. Yeah. No. Okay, this is a part of Russia, and you can see the location in winter. In winter, yeah, you can see the weather there. In winter, they can have like in January, for example, they can have like -20, okay? And the highest amount is -12. Okay, and in the worst situation, they can have even during the night time, okay, -50 degrees of Celsius. Okay, it's very hard to live there, and the people would not go out to work at all. It's very hard to get out of the home, and yeah, there will be always the snow. And image. Okay, it's very cold there, and yeah, we get the temperature, which is really less than freezing point of the water, and we would say it's a negative number in degrees of Celsius. Okay, and the CSS scale is used both in everyday life and in science and industry. If you plan to work as scientist on the laboratory มีคนถามผมครับผมหยุดแน่นอนเสียงหายครับเป็นสิทธิ์บอกผมเสิร์ฟที่คือมันจะมี2 ช่องนะคุณลองดูก็ได้นะดังนั้นจะใช้ไมโครโฟนอันนึงไม่รู้ผมส่งลิงก์ให้คุณได้ไหมลิงก์ให้ครับอันนั้นจะเห็นตัวผมด้วยนะอันนี้เห็นแค่หน้าจอที่ YouTube ตอนนี้ก็มีคนดูประมาณ2 คนแต่ลิงก์อันนี้มันแต่ YouTube ที่คุณดูนี่มันเป็นมาจากซูมอ่ะถ้าซูมเสียงหาย YouTube ก็จะเสียงหายด้วยแต่ว่ามันจะมี YouTube อะไรที่แบบพิเศษเลยออกเสียงหายเสียงมาแล้วหรือยังครับเสียงกดคุณเข้าได้ว่าคือผมเข้าใจว่าการที่ไม่มีสองลิงก์ที่ผมส่งพิมพ์ไปในไลน์ครับไม่ It's private เพราะว่าพวกสิ่งมัน private หรือเปล่าผมไม่รู้นะครับเข้าไปไม่ได้จริงด้วยนะเซตเป็น private หมายก่อนโอ้โหหมายก็ไม่ได้เลยตั้งทำเป็น private ผมแบบเซตเป็น private เข้าไม่ได้เลยหน้าไม่มีคนไปดูที่อะไร Okay. Yeah. มาเดี๋ยวลืมเรื่องเราครับyeah. If you plan to work in the laboratory every day, okay, you may have to know you may have to use the Celsius degree in if you plan to work in as engineer, okay, all right. Yeah, you may also have to face with theน่าจะเข้าได้นะครับนั้น Yeah, if you plan to work in as engineer in a factory, like many students of mine, yeah, in the factory, they also use the degree of Celsius, the Celsius degree. Yeah, you can see that Celsius degree is used for lots of application. Yeah. Now, but in some countries, like in the United States, we don't use these units. It's called we would rather use Fahrenheit. Okay, in English-speaking countries, except for United States too, they use Fahrenheit. The Fahrenheit is the same from Daniel Fahrenheit. I think it's Polish. Fahrenheit scale is still the most frequently used temperature unit in the United States, and has the freezing point, the freezing points of water at 32 degrees of Fahrenheit and boiling point at 212, okay, which is 180 degrees as difference. Okay. And what else? Yeah, if you look at the scale or both scales on the same thermometer, you will see that the boiling point is at 100 degrees at the Celsius side, and you will get 212, okay, on the Fahrenheit side. You get the freezing point 0 degree on the Celsius side. You get 32 degrees of Fahrenheit on the Fahrenheit side. And the human body, the normal temperature for the human body is 37 degrees on Celsius scale and 98.6 degrees on the Fahrenheit scale. And the room temperature is considered to be 20 degrees of Celsius and 68 degrees on the Fahrenheit scale. Okay, but it's not easy to find 20 degrees of Celsius outside in Thailand. Okay, I don't know why they say it's room temperature. Maybe it's room temperature if you turn on the air conditioner heavily. Okay, yeah, but those two scales are not the only scale that is used around the world. Okay, in daily life, okay, both scales will be sufficient. But if you work in a special area in physics or in many applications in chemistry too, you may have to consider the next temperature unit, which is this one. Okay. How does the temperature how does this temperature unit emerge? Okay. They just scientists have many scientists have a chance to do the experiment about the phases, okay, the states whether it's liquid, solid, or gas of many things, and they have a chance to see the behavior of several kinds of gases. For example, this one in if they control the volume of the gas to be constant, and to keep the volume of the gas constant, and if they let the temperature be higher, what they could observe is the increasing amount of the pressure. Okay, there is an increasing pressure too. Okay, in they have tried. They have done this experiment for many things, many types of gases. For example, the red one is the first experiment for the first gas, and the blue one is the same experiment. When you increase the temperature, you get higher pressure. Too, in the last one, they use three different types of gases. And beyond the temperature by water freezing, the water freezing points, they expect that if they plot everything onto the appropriate scale, which is observed, all these experiments tends to bring you to the same point. Okay, when the same point where we cannot find any lower temperature possible, and we will not find any lower possible temperature anymore. And this is the same point for every gas. Okay, and they found that the heating point here on the x-axis, on the temperature axis, is equal to minus 273.15 degrees of Celsius. Okay, so when they know that 233 degrees of Celsius is no longer appropriate, it's no longer convenient for every people to use, they just build up the new temperature scale. Okay, but the pitch or the resolution will be the same as the Celsius scale. Okay, because that's the scale that most people use. All right. And here is the reason why it comes to this scale. Okay, this scale is was in part discovered by this person, and it's called Kelvin scale. Okay, but Kelvin is not like Celsius or Fahrenheit. Kelvin is the surname of this ordinal. It's not the name that he was born. He was born. Okay, his actual name is William Thomson, but if you have done something good to the society, to the community, you will get the special rank. Okay, like imagine that if you watch the soccer or football in soccer in American, or football in other parts of countries, in other part of the world, we would say football as the soccer, right? But in the United States, you have to say soccer. Otherwise, if you say football, it's gonna be the American football, NFL and so on, right? And but imagine that if you are the trainer of the soccer team like Manchester United, but I'm not the fan of Manchester United. Okay? And you know that there is a person who is the trainer or the coach of Manchester United. And he was born like normal people, and when he has done something good to the squad to Manchester United, he got several prizes, he transferred the league and so on, right? And he has got the rank which is called Sir, like this. And typical British system, they have also the rank like Baron Kelvin, and William Thomson was the first person who got this spatial rank. Okay, and the temperature scale just follow his name. Okay, maybe he got the rank due to his contribution, his work in science or in physics. Like that. Okay. นะครับประเทศไทยผมไม่รู้นะถ้าคุณเป็นนักฟิสิกส์ไปเรื่อยๆคุณพบอะไรคุณอาจจะได้รับตำแหน่งยศอะไรก็ได้นะหรืออาจจะได้รับเครื่องราชอิสริยาภรณ์อะไรอย่างเงี้ยคล้ายๆกันนะครับเพราะว่าไทยก็ไปใช้ลักษณะสังคมอย่างเงี้ยคล้ายๆกับประเทศอังกฤษ All right. Kevin is not the actual surname of any person, but it's the surname of this person, of this rank. Okay, we have to deal with Kelvin scale because it's the temperature that is commonly used in science. Okay, if you want to work in laboratory, you cannot avoid to work to use it, especially in the faculty of science. For us in engineering, we would not often use the Kelvin scale. Okay, I have never heard the Kelvin scale in engineering. Okay, except that you work in faculty of science, you fall in love with chemistry, you fall in love with physics. If you want to work there in the university with this stuff, okay, you have to do Kelvin scale. Okay. It's like if you live in the United States, you are gonna say your height in terms of foot or feet, right? 6 foot, 6 feet, 32 feet, something like that. Okay, and you say your weight in pound rather than kilogram. All right, yeah, that's the thing. And you would say the length in inch or foot or something like that. Yeah. Kelvin scale is special for the people in laboratory in science, and this temperature scale is quite unique because it's defined to have 0 Kelvin for any substance in the space. Okay, the scientists believe that you cannot get minus or negative infinity Celsius or minus infinity Kelvin. Okay, it's impossible. Okay, it's not on the real life like mathematics. In physics, you have to rely on the truth. Okay, they found that 0 Kelvin or minus 273.15 is the lowest possible temperature of anything in the space. Okay, you cannot get the temperature less than this. Okay, and that's the thing that you have to rely on. And yeah, so because of this reason, they would say that Kelvin scale is the absolute scale for the temperature. And what is the reason why they say absolute? Because the 0 value on the Kelvin scale is the lowest temperature that you could have for any stuff. Okay, what is the reason why they say the absolute 0 temperature? Because Baron Kelvin has found that when we are at 0 Kelvin, the molecules stop moving. Okay, they don't move at all. When they don't move, there will be no kinetic energy. You know kinetic energy, right? The energy due to the movement of any particle, and it can be found from the expression that you may get used to, right? It's 1/2 mv square, right? Yeah, at that temperature, you will get 0 motion for anything. So in that situation, there will be no kinetic at all. Okay, kinetic energy at all. Yeah, so that's why they say it's absolute 0 and absolute scale, temperature scale. Absolute 0 is the temperature at which everything, including air, freezes solid. Okay, if someday, if our body can sustain or stay in that environment minus, let's say 3.15 degrees of Celsius, if human can stay like that, you will see that the air will get the solid phase. Okay, there will be no no gas form of the air anymore. And I don't know in that situation how would we breathe then. Yeah, because when the molecules or the atom of the air don't move, okay, there will be no energy. Then when there is no energy, the matter is gonna stay in solid phase. Okay, very low internal energy. So unlike temperature scale, temperature is an absolute scale. Okay, the other scale like Celsius, Fahrenheit, and you know that there is an additional temperature scale. What is that? The one that I didn't say in this lecture. There is also another temperature scale. Have you ever heard that? Maybe during your time in vacuum 3, vacuum 4, vacuum 5, you may have ever heard that temperature scale, but it's not at present. It's not said in this lecture notes, in this lecture, in this SCI33205. What is that temperature scale? คุณคิดว่าหน่วยพลังงานหน่วยอุณหภูมิเลยนะที่มันยังมีอยู่แต่ว่าเราไม่ได้พูดกันเลยนะว่าหน่วยพลังงานอุณหภูมิหน่วยอะไรครับที่ยังไม่ถูกกล่าวถึงและในนี้ก็จะไม่มีกล่าวถึงด้วยมีนะคือเซลเซียสมีฟาเรนไฮต์มีเคลวินนี่อีกอันหนึ่งอะไรครับเปิดไมค์ตอบได้นะหรือว่าพิมพ์มาก็ได้ใครตอบได้ไหมครับมีแน่เลยที่ซูมเป็นยังไงบ้างซูมเหลือ2 คนเหมือนเดิมครับเอาไรเข้ามาพิมพ์ชื่อแล้วก็หนีกันไปแล้วทุกคนครับมันหลุดไปจริงครับแต่ว่าสั่งอัดแล้วครับก็น่าจะอยู่ในนั้นครับมีหน่วยหนึ่งของอุณหภูมิไม่ใช่แบบว่าสอนไปพาคุณไปโลกแคบๆนี้ไม่ได้บอกให้รู้กว้างทั้งหมดเดี๋ยวจะเขาแบบเรียกว่าไงรู้ไม่กว้างแล้วก็เอามาบอกคุณครับคุณก็ต้องบอกคุณนอกเหนือไปจากนี้มันยังมีหน่วยอุณหภูมิการเรียกว่าอะไรใครตอบได้ครับที่ YouTube นะครับมี กดวงวัดนะอยู่นะแล้วก็แล้วมีคนอยู่ที่ YouTube มีเหมือนเดิมนะครับมีนนทกรกับปนทัศน์2 คนนะครับคิดว่ามีอะไรหน้าที่อาจารย์ยังไม่พูดเต็มจริงๆนะคุณผมก็ไม่เคยเห็นเขาใช้กันหรอกนะครับแต่ว่าเรียนมามีอยู่เคยมีสมัยม.เหมือนคุณหน่วยอะไรครับอีกอันหนึ่งหน่วยอะไร What is the next What is another temperature unit that was not discussed yet in this lecture? Another temperature unit is Romer. Okay, you know Romer. รู้จักอุณหภูมิหน่วยโรเมอร์นั่นแหละนะครับโรเมอร์ไปศึกษาเองครับกดโรเมอร์ ROMER ในอินเทอร์เน็ตมันก็เป็นหน่วยอุณหภูมิกันเอาละในที่นี้เอาเท่านี้นะเพราะว่าแค่นี้ก็สอนอยู่แล้ว All right, yeah, Romer is another temperature unit. Yeah, here we have the volume of gas in the flask and long is kept constant by raising and lowering the reservoir B. Maybe we can lift it up and look down, make it lower. Keep the mercury level in column A constant. วิธีทำให้ปริมาตรแก๊สมัน เท่ามันคงที่ครับก็คือว่าเอาไอ้เนื้อเทาเนี่ยนะครับน้ำสีเทาก็ซึ่งอาจจะเป็นตลอดก็ได้ครับพยายามให้มันอยู่ในเส้นเดียวกันให้มันอยู่สูงตลอดเนี่ยเรียกว่าสูงสมมติคุณเพิ่มลดอุณหภูมิแก๊สมันจะขยายตัวยังไงก็ตามครับคุณพยายามถ้าแก้วขยายตัวคุณต้องเอาขึ้นครับเอาขึ้นนะเพื่อว่าให้แก๊สมันชี้ที่สูงให้น้ำระดับน้ำสีเทาชี้ที่สูงเลยตรงนี้มันดันมากเราก็ต้องยกนี้ขึ้นให้มันดันหรือว่าเอาลงนะผมว่าเอาลงน่าจะเอาลงถ้าเอาลงปุ๊บมันก็จะดันนะพอคุณให้พลังงานครับแรงดันมันตรงนี้มันสูงนะเราก็ต้องมาลงครับพอคุณหยุดให้พลังงานไม่ให้ความร้อนมันตรงนี้พลังงานจะต่ำความดันก็จะต่ำเลยยกขึ้นจะให้ตัวระดับน้ำมันชี้ที่สุดเลย This is another constant value gas thermometer. It's not the thermometer like this. The thermometer that use the liquid property expansion is the thermometer that we use. You may find in hospital or in a health center, right? In COVID or pandemic situation, you have to see the thermometer, right? And yeah, with this principle, the actual constant volume gas thermometer can be found in our real situation. And here is the place that we keep the air there, that we can observe the temperature. All right, this is what we have already discussed about zero. Let's talk about the temperature scale that can happen, that exists in nature. You know that the lowest temperature of anything could be zero, right? But what they found is something very, very close to zero, which is 10 to negative 10. And let's consider somehow like 2 Kelvin. We have helium. Helium is usually a gas, right? It's an inert gas. And at this situation, at 2 Kelvin, 2 degrees of Kelvin, the helium changes its phase from gas to liquid already at this level. All right, and if you go further at 20 Kelvin, the hydrogen, hydrogen, right? H2. Usually H2 or hydrogen is a gas, right? It has only gas phase, but at this position, at this temperature, the hydrogen changes its phase from the gas to the liquid. Okay, let's consider another type of gas, which is nitrogen. Nitrogen will be in liquid form at somehow like 70 degrees of Kelvin, and of course for us it's 273.15, right? The water changes its phase from the liquid to the solid one, which is the freezing point. And copper, right? Copper is used as the conductor, right? And many other stuff like device for heating and so on, right? Crucial stuff and so on. Copper is used for that application, but if you are at 1000 Kelvin, for example, it's around 700 blah 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 degrees of Celsius. Okay, it's 700 Celsius degrees of Celsius. That's the melting point of copper. Copper will change its metal phase to liquid phase. All right. But if you are interested more, okay, above 700 Kelvin, we would have around 6,000, 5,000, 6,000 Kelvin, which is again around 5,000 or 6,000 degrees of Celsius. You are at the surface of the sun, okay? Because it's very, very hot, 6,000, and everything is going to be burned at that position because คุณรู้ใช่ไหมครับว่าขออภัยนะไม่ทราบว่าคุณศาสนาอะไรแต่ว่าเท่าที่ผมดูข่าวแล้วเตาเผาวัดนะครับเตาเผาวัดเนี่ยคุณรู้ไหมเขาใช้อุณหภูมิเผาเท่าไหร่มีโควิดคนเสียชีวิตเยอะเขาใช้อุณหภูมิเผาเท่าไหร่ครับอะไรทุกคนอยู่ครับรู้ไหมเลยว่าเขาสุดโควิดวัดบางวัดวัดที่เขาสนใจสภาพสิ่งแวดล้อมเขาเผาศพที่อุณหภูมิเท่าไหร่ทำไมว่าเผาแบบสนใจสิ่งแวดล้อมก็คือเผาแบบไม่ให้มีเขม่าไม่ให้มีควันแต่ให้ออกมาใส่พริกเลยโดยเฉพาะวัดที่อยู่ในกรุงเทพมหานครเพราะว่าเอาเป็นดำปื้นๆแล้วมันไม่ได้แล้วเพราะมันตกใส่เสื้อผ้าคนตาคนใช้ชีวิตอยู่อากาศหายใจในสิ่งนี้นิดหน่อยดังนั้นวัดที่เผาศพก็จะต้องเผาแบบไม่ให้มีเขม่าเลยคุณรู้ไหมเขาเผาที่มีใครเปิดในต่อได้ไหมพิมพ์ใครอยู่ยูทูบพิมพ์ก็ได้นะเขาเผาที่อุณหภูมิประมาณ 1,000 องศาใช่ไหมซึ่งอันนั้นเป็นอุณหภูมิที่สูงมากนะก็คือหลอมเหล็กให้แบบละลายได้เลยเพื่อไม่ให้มีเขม่านะให้ควันออกจากหลอมควันตรงเมนครับใส่พริกเลยเขาต้องเผาที่1,000แล้วค่าดูแลใช้จ่ายสูงมากครับโดยเฉพาะอุปกรณ์ที่เตาเผาตัวปูนของตัวเมนนี้ก็แตกร้าวแล้วคุณนึกดูนะครับที่ผิวของดวงอาทิตย์เนี่ย surface of the sun we are at 5,000 6,000 degrees of Celsius or degree of Kelvin there is no difference at all when we are talking about several thousand of degrees of temperature alright yeah you know that it's extremely high much higher than the temperature that we use to burn the body of people from the pandemic situation. All right. And you may ask me, how could the physicists or the scientists say the surface of the sun has a temperature of 5,000 or 6,000 degrees of Kelvin? You may ask me this. คุณทราบไหมว่าทำไมนักฟิสิกส์หรือว่านักวิทยาศาสตร์บอกว่าที่ผิวของดวงอาทิตย์มันประมาณ 5,000 องศามั่วหรือเปล่านั่งมโนหรือว่าเขานั่งยาเราไปวัดอุณหภูมิเอาเทอร์โมมิเตอร์ไปจิ้มอยู่ตรงนั้นหรือเปล่า What is the reason นะครับไม่ใช่แบบว่าเรียนแล้วก็สอบจบอะไรนะทำดูในเอกสารประกอบการเรียนของอาจารย์ไม่ต้องทำเลยมากวิธีทำก็ชัดเจนตรงๆก็สอบจบผ่านวิชามันใช่เลยแค่นั้นนะคุณต้องอยู่ในกรรมสภาพความจริงนะผมไม่ได้สอนแมทนะครับหรือแมทมันค่อนเกี่ยวข้องกับโลกความจริงแต่ว่าฟิสิกส์มันคือวิทยาศาสตร์มนุษย์พยายามสร้างสิ่งที่มีอยู่รอบตัวในธรรมชาติ So what is the reason why scientists or physicists could say the surface of the sun is at the temperature of 5,000 to 6,000? By which sense? Because they use the light they emit from the sun to predict the temperature. The scientists use the photon or the light spectrum to determine the temperature of anything because we would not have enough money to build up the spacecraft to reach the surface of the sun. What we could do is to build up a very, very giant, big telescope to observe anything around the Earth or in the deep space. Okay, and in solar corona, in some area in the space, they have temperature around 1 million Kelvin โอ้ไม่ต้องพูดถึงครับถ้าเป็นล้านนี่มนุษย์ไฟไม่หลงเหลือเป็นเผาเกลี้ยงหมดนะเห็นไหม and inside the sun the interior of the sun we have 10 million degrees of Kelvin. It's extremely hot. And hydrogen bomb, okay, which is a kind of process that could happen in deep space. Actually, it's kind of nuclear fusion effect, like nuclear fusion process. Right? Yeah, the temperature of this process is 200 million degrees of Celsius. You can see that this is impossible for scientists, which is also as same as they are also human. They could observe this. They could not build up any thermometer that can support 100 million degrees of Celsius. The scientists just used the light spectrum that could be observed from the telescope on any spatial device. And they convert the color of that spectrum to the temperature somehow. If you want to see the detail, you just study in the faculty of science, or you just browse it from the internet. You don't have to attend the faculty of science. You can go ahead with your future. If you want to become a doctor, just go ahead with doctor. And if you want to see how the scientists interpret the light spectrum as the temperature, you just find a spatial reading or book about that. Okay, I'm not from the faculty of science. I don't know the method how the physicists or scientists convert the light spectrum to be the temperature scale. All right, let's move to the next thing. If we compare all those three temperature scales, Celsius, Fahrenheit, and Kelvin, you will see that freezing point of water is 0, and on Fahrenheit 32, and on Kelvin is 73.15. The steaming point or the vaporizing point of the water is 100 degrees of Celsius to the 12th degrees of Fahrenheit to the 33.15 degrees of Kelvin. Okay, and yeah, normal temperature is 35, right? In Fahrenheit, you say 98.6 degrees of Fahrenheit. Okay, if you wanna do the PhD, if you want to study the doctoral degree in the United States, okay, the people use Fahrenheit scale, you have to remember this number, 98.6, okay, which is your body, your normal temperature for the normal temperature for the body. Okay, and on the Kelvin scale, it's going to be 10.15. All right, and anything else? Oxygen will be in liquid form in 90 degrees of Kelvin, minus 195 degrees of Celsius, and minus 298 degrees of Fahrenheit. And the carbon dioxide changes its phase from gas to the solid at 195 degrees of Kelvin and negative 78 degrees of Celsius and negative 109 degrees of Fahrenheit. Okay, and yeah, these two levels are these 2 points are already discussed. Okay, now we are at the main the main interest for us is the conversion of temperature scale. As you know, we have 3 temperature scale in 4, right? Celsius, Fahrenheit, and Kelvin. If you want to convert the temperature from Celsius to Fahrenheit, you have this formula. Temperature in Fahrenheit is 9.5 of temperature in Celsius plus 32. If you have Fahrenheit and you scale, you want to convert same temperature to Celsius, you have to use this formula. its temperature in Celsius is equal to 5/9 of the difference between temperature in Fahrenheit minus 32, right? Celsius to Kelvin is quite straightforward. You just add 273.15. If you want to get Kelvin from Celsius, you just reduce or subtract the temperature in Kelvin by 273.15. All right, and Fahrenheit to Kelvin is equal to 5/9. Okay, 5/9 of temperature in Fahrenheit minus 32, and this is the value you get in Celsius here, right? But if you want to convert to Kelvin, you have to add 273.15 according to this formula. If you combine these two formulas here, you get this expression. And if you want to get Kelvin from the Fahrenheit, you have to convert first the Fahrenheit to Celsius like this, okay, and you convert the Celsius to Kelvin by using this formula. Okay, you combine these two formulas together, okay, substitute this one into this one to get the Kelvin Fahrenheit. Okay, that's the whole theory. Okay, you can choose any way the combination. It depends on the input and output, what you want to get as the outcome. And yeah, the way to get the temperature difference is like this. Okay, the temperature difference between Fahrenheit and temperature difference in Celsius is somehow like this. Let's consider room temperature. If we define as 25, okay, unlike the former one, they say 20 degrees of Celsius as room temperature. Okay, it's in the minor situation, though. The situation that we could live well, it's 25 degrees of Celsius, and yeah, this could be possible if you turn on your air conditioner in Thailand. Yeah, the room find the room temperature in degrees of Fahrenheit, find the room temperature in Kelvin. Okay, yeah, 25 right? มีใครจะทำไหมไม่มีครับถ้าปกติห้องซีนผมจะเรียกให้ทำนะตรงนี้ทุกคนทำได้ไม่ได้ครับได้เป็นกันตั้งแต่ชั้นป.ต้นแล้วไปซ้ำนะครับ Okay, anyway, it's my task to show you how to do that, right? We want to get room temperature in Fahrenheit scale, and we have to say it's 9/5 temperature in Celsius, but in I think it's plus 32, right? Yeah, 9/5 9/5 plus 32, and you leave it the 25, right? 9/5 of 25 plus 32 is equal to 45 plus 32, right? It's going to be 77 degrees of Fahrenheit. All right, that's the first equation. Okay, the first solution for this problem. And the temperature in Kelvin, right? Temperature in Kelvin is quite easy. You have TK, and if you have TC, you have to add it by 273.15. Okay, in this case, we get 25 plus 73. จริงๆคุณเอาแค่273ก็ได้ไม่ต้องมาบ้าที่มาผม273 So it's going to be 298.35 degrees of Kelvin. All right, and that's it for this example. All right, yeah. Let's at next example. But this will involve some special vocabulary. The temperature gradient between the skin and the air is regulated by the continuous blood flow. Sorry. โอเคก็คือเขาบอกว่าการเปลี่ยนแปลงอุณหภูมิครับระหว่างผิวหนังและอากาศภายนอกครับของคนนะครับถูกควบคุมโดยเส้นเลือดฝอยที่ผิวเราสิเรียนอะไรนะเรียนฟิสิกส์มันไปเกี่ยวข้องกับชีวะได้ด้วยนะเห็นไหมวันนั้นเส้นเลือดฝอยนะครับเป็นสิ่งที่อุปกรณ์คือร่างกายมนุษย์เนี่ยโอ้มันสุดยอดมากครับมันสามารถปรับอุณหภูมิตัวเราด้วยการปล่อยเลือดไหลไปตามเส้นเลือดฝอยเจ๋งไหมอ่ะเยี่ยมไหมครับif the cutaneous blood vessels are constricted the skin temperature and the temperature of the energy will be about the same ก็คือสมมติคุณไปที่หนาวเส้นเลือดฝอยมันหดตัวไม่ยอมให้เลือดมันไหลไม่ยอมให้เลือดไหลตามผิวเขาไม่มีการเอาของอุ่นไปวิ่งรอบตัวของเราแขนของเราจะเย็นมากแขนของเราเนี่ยจะเท่ากับอุณหภูมิข้างนอกเลยก็คือเรื่องมีปัญหาแล้วเลือดฝอยหดตัวไม่ยอมให้เลือดไหลก็คือรักษาอุณหภูมิร่างกาย when the vessels are dilated more blood is brought to the surface เมื่อเส้นเลือดมันขยายปุ๊บเลือดมันก็จะวิ่งไปทั่วตามผิวหนังเราก็จะเป็นไงครับไม่ใช่เลือดฝาดเลือดแดงแก้มแดงหมายถึงว่าตัวเราก็จะอุ่นขึ้นอุณหภูมิสูงขึ้นเห็นไหมนั่นคืออัจฉริยะของมนุษย์นะคือเรียนวิศวะได้นะครับณปัจจุบันนี้นะคุณจะคิดอัลกอริทึมอะไรก็ได้ให้มันฉลาดเท่าระบบปฏิบัติการของร่างกายมนุษย์เนี่ยที่มันสู้เชื้อโรคได้คือว่าถือว่าเก่งมากเลยนะแบบมีระบบนิวรอนคือแบบมีส่วนควบคุมที่สุดยอดมากร่างกายนี้ครับณปัจจุบันวิศวกรรมยังไปได้ถึงนะพูดได้ประมาณนี้นะยังฉลาดไม่สู้ร่างกายเลยเนี่ยแค่ระบบปรับอุณหภูมิร่างกายตัวเองโอ้โหอัตโนมัติได้ขนาดนี้ครับดังนั้นรักษาสุขภาพร่างกายคุณให้ดีๆนะครับเห็นไหมมันเป็นระบบที่ผ่านฉลาดมากแล้วนะครับอย่าให้พังเสียหายครับเก็บไว้ใช้เอาไว้สร้างให้คุณเจริญงอกงามไปข้างหน้าในอนาคตนะครับ Suppose during duration of the skin warms 72 degrees of Fahrenheit to 84นะเริ่มมีการกระจายเลือดเข้าไปในร่างกายนะครับทำให้อุณหภูมิคุณสูงขึ้นจาก72 ฟาเรนไฮต์ถึง84 ฟาเรนไฮต์คือมันพูดรู้เรื่องถ้าคุณอยู่ในอเมริกาอยู่ในสเตทเห็นไหมมันรู้เรื่องแต่เรามันไม่ได้อยู่อเมริกาคุณพูดมาฟาเรนไฮต์แล้วใครคนก็จะงงเห็นไหมครับหรือว่าคุณไปฉีดวัคซีนแล้วคุณบอกอุณหภูมิคุณอยู่ในหน่วยเคลวินอย่างเงี้ยคุณหมอคุณพยาบาลคุณแพทย์นี่งงตึงนะครับเห็นไหมเขาไม่ค่อยใช้เคลวินกันเห็นไหมครับเขาใช้แต่ดีกรีของเซลเซียสนะครับหรือคุณจะไปพูดฟาเรนไฮต์กับคุณหมอที่ประเทศไทยนี่ก็คุณพยาบาลหรือคนเจ้าหน้าที่ก็จะงงตึงเหมือนกันดังนั้นเปลี่ยนหน่วยให้เขาเสียก่อนนะครับเห็นไหม so let's consider the first problem convert these temperatures to Celsius and find the difference and convert the temperature to Kelvin again find the difference okay we want to convert the temperature from Fahrenheit scale right to the Celsius scale right in one thing I forgot to mention the Kelvin scale okay the Kelvin scale doesn't require the small circle at all okay K has no small circle you can see here Fahrenheit has degree Celsius has degree symbol which is small circle but Kelvin doesn't have it doesn't need degree at all what is the reason behind it because Kelvin scale is the absolute scale okay no other matter substance can reach the negative 273.15 okay so we don't write down the degrees or the small circle anymore for Kelvin scale all right that's the typical way อยากเขียนวงกลมมานะเขียนวงกลมมาเสลอนะครับเขียนมา so the next question is convert the temperature from Fahrenheit to Kelvin So it's not difficult in this case whenever you are able to convert that temperature to Celsius. All right, so let's go on to the next thing. We first consider the temperature at 72 degrees. Oh, it's a Fahrenheit, right? And the second one, we'll see later. The second one. Okay, at the 32 Fahrenheit, if you want to convert it to degrees of Celsius, it is possible to just say PC is equal to, it's 5 by 9, right? 5 by 9 and TF minus 32, right? Yeah, and we have to substitute right now 5 by 9 and what is that? 32 72 minus 32 is going to be 5 by 9 of 40. Okay, and you have to multiply this, and it's going to be 200 by 9, and use the calculator. Use the calculator. $200 by 9. Okay, it's equal to 22.22. Okay, it's around 22.22 degrees of Celsius. Push. Is that all right? I'm not sure. 72 to 22. 72.2 Celsius. Yes, it's all right. It's correct. Okay. And what about this temperature in Kelvin? So TK is going to be TC, right? Plus 273.15, and it's going to be 22.22 plus 273.15. I think we are running out of time. To my 5.37 Kelvin. Okay, and here degrees of Celsius, and in the second stage, at the temperature of 84 Fahrenheit, you can get TC from this expression. 5 by 9 of TF minus 32, yes, and 5 by 9, and TF is 84 minus 32, you get 5 by 9 of 52, right? And it's going to be 60 by 9. It's equal toแต่เริ่มต้นนะครับอุณหภูมิควร22 องศาขึ้นถึงร้อยแล้วก็ต่ำ 60 is going to be 28. Okay, 28.89 degrees of Celsius. Okay, เพิ่มเยอะโอเคครับจาก22มา28เกือบ29 องศาครับเพิ่มเป็นเลือดปล่อยเลือดเลี้ยงไปตามเส้นเลือดฝอยนะครับร่างกายจะทำ so we're gonna find the third thing. Okay, the delta temperature. The temperature in in Celsius and Kelvin, right? TC, delta TC. So what is that, right? And delta TA, what is that, right? So what is delta TC? Delta TC is going to be what is that? Oh, I forget to say T Kelvin in this situation. T Kelvin is going to be TC plus 273.15, right? Which is 28.89 plus 273.15, right? And here it's going to be it's going to be 4, 9, right? 0 and 1, right? 9, 1 point. Yes, and it's in theory, right? In the second step. Okay, delta TC is going to be 28.89 minus 22.22, right? It's going to be 6.67 and degree of Celsius. And for the delta TK, difference of temperature in Kelvin scale, it can be the same thing actually. 301.04 minus 295.37, and you get 7 and 6 and 6 again. Okay, you can see that the difference of temperature whether in degrees of Celsius or Kelvin will be the same. It's 6.67. And now we reach the final example. Normal physical body for human is 98.6 by 1027 in Kelvin. And the first situation first. Okay. The first situation we have 98.6 degrees of Fahrenheit. And we want to find the temperature in Celsius TC is how could we find that? It's 5 by 9, right? 5 by 9 of TF minus 32, and you get 5 by 9 of 8.6 minus 32, and it's going to be 5 by 9 of 6.6 and 6, okay, 3 times of yeah, 6. 6, 3 times of number 6, and you get, I think, 37 degrees of Celsius, I think, right? And let me check if I want to get something wrong. And that's why that will be my mistake. 5 by 9 times 60. It's 37 exactly. Yeah. Yeah. Okay. The value in Celsius and temperature in Kelvin is going to be 273.15 plus TC. Okay, which is 273.15 plus 37, and it's going to be 310.15 degree of Kelvin. Okay. Let's consider the second situation. They say when human is relaxing on a couch, okay, you sit down on a couch, your body is clever, right? It's intelligent. The skin temperature is reduced, okay? They will not let the blood flow around your body, okay? And then your body is going to be cooler, okay, and that the cooler amount is 2 degrees Celsius reduction in than the internal temperature. And how much lower is the steam temperature? In Fahrenheit degrees and in Celsius, you have the change of temperature by the second situation. You have the difference of temperature in Celsius by 2 degrees of Celsius, and you want to convert it to Fahrenheit, right? So you have to do this expression. This one. This one. Delta TF is number 5 of delta TC. Okay, delta TF is number 5 delta TC. So we use this one. This is that expression delta TF is 9 by 5 delta TC. So you have difference as number 2, right? So you just multiply it, and it's what is that? 19 by 5, right? 19 by 5. It's going to be 3.6 degrees of Fahrenheit. All right, and that's it. And if you consider the difference of the temperature in Kelvin scale, delta TK is going to be exactly the same as delta TC, okay, which is 2 degrees of Kelvin. Okay, all right, we complete all of this stuff. We are running out of time 6 minutes later. โอเคครับวันนี้ก็จบเรื่องเกี่ยวกับการเปลี่ยนหน่วยของอุณหภูมินะครับก็เริ่มต้นของวันนี้เหรอครับก็กล่าวเกี่ยวกับเรื่องยูนิตอุณหภูมินะครับที่หน่วยของอุณหภูมินะเริ่มจากเซลเซียสเลยนะครับเห็นไหมเริ่มจากอันเดอร์เซลเซียสนะครับก็คือหน่วยเซลเซียสนะครับก็ว่ากันไปครับใช้ทั่วโลกครับก็ฟาเรนไฮต์ครับใช้โดยเฉพาะประเทศสหรัฐอเมริกาแล้วก็ประเทศที่ใช้ภาษาอังกฤษหลักนะครับอาจจะติดกับใต้ด้วยอะไรอย่างนี้นะครับผมก็ไม่เคยไปครับก็พูดถึงสเกลครับวัดจากจุดแข็งตัวของน้ำแล้วก็จุดเดือดของน้ำนะครับแล้วก็มาอุณหภูมิที่นักวิทยาศาสตร์ใช้ไม่ใช่แค่ในห้องทดลองครับวันนี้มันจะเน้นไปเกี่ยวกับสารที่อยู่นอกโลกด้วยนะครับเห็นว่าอุณหภูมิแบบสุดขั้วจริงๆครับนั่นคือเปลี่ยนสถานะก็สุดๆครับนั่นคือเคลวินครับก็เป็นยุคใหม่ของหน่วยอุณหภูมินะครับก็มีสูตรในการเคลวินหามาได้จากการที่นักวิทยาศาสตร์วัดแก๊สนะครับแล้วก็คิดว่ามันน่าจะโปรเจกต์ไปยังค่าหนึ่งนะครับก็ไม่แน่นะคุณอาจจะเป็นนักวิทยาศาสตร์ที่ใหม่นะอาจจะค้นพบสิ่งใหม่ๆนะครับเพราะว่ายังไงผมก็เป็นคนรุ่นเก่าแล้วนะผมฟังได้แต่พลังงานความสามารถคุณครับก็สเกลต่างๆของอุณหภูมิที่อยู่ในวิชาฟิสิกส์ที่เราสามารถรู้สังเกตได้นอกโลกนะครับตั้งแต่ไฮโดรเจนบอมปฏิกิริยาอินเตอร์ฟิวชันนะครับแล้วก็ภายในเลยนะของดวงอาทิตย์นะครับประมาณ10 ล้านอันนี้100 ล้านนะครับปฏิกิริยาอินเตอร์ฟิวชันแล้วก็ตัววงแหวนโซล่ารอบดวงอาทิตย์ประมาณ1 ล้านครับแล้วก็โซล่าโคโรนาก็คือวงแหวนของสุริยะนะแล้วก็เซอร์เฟซของดวงอาทิตย์ก็ประมาณ5,000 ล้านแล้วก็นะครับอันนี้จะเป็นในโลกแล้วนะครับจุดหลอมเหลวของทองแดงแข็งจุดแข็งน้ำอะไรพวกนี้นะครับเป็นในโลกหมดแล้วนะแล้วก็อุณหภูมิสเกลต่างๆหรือว่าพิชหรือว่าความถี่ของบาร์แก๊สนะครับบนฟาเรนไฮต์ก็จะแน่นกว่าพวกเคลวินและก็เซลเซียสนะครับแล้วก็สเกลต่อสเกลนะครับจุดเดียวกันนะครับอุณหภูมิห้องอุณหภูมิร่างกายมนุษย์นะครับก็จะมีนะครับในค่าแบบแล้วเราก็มาถึงสารพวกแก๊สนะเปลี่ยนเป็นของแข็งออกซิเจนเปลี่ยนเป็นของเหลวอะไรอย่างเงี้ยครับหรือว่าเก็บอะไรนะวัคซีนไฟเซอร์แล้วลบ70 องศาอะไรเงี้ย มาถึงเรื่องการเปลี่ยนแปลงอุณหภูมิครับจากสเกลนึงเป็นสเกลนึงต้องมีสูตรต่างๆให้ดังนี้นะครับแล้วผมก็พาหาการดูตัวอย่างครับ3ตัวอย่างในการเปลี่ยนอุณหภูมิให้ดูนะครับเห็นไหมการทำให้ตรงนี้แล้วเดี๋ยวคอนเวิร์ตไฟล์ส่งให้นะใครยังไม่ได้เขียนชื่อโปรเขียนชื่อครับso we're gonna finish our lecture right now. It's noon. Okay. See you on next Thursday, right? สวัสดีครับบ๊ายบายครับ No one is here. Okay, only no thought for one. Thanks.